So we talked about optimization, and in optimization, basically we were looking at, how to maximize or minimize a certain quantity. Related rates are a different class of problems, which involves finding a rate when two things are changing. Okay? So for example, as the radius of something is increasing, so is the area, right? And so what you have to do is you have to find the rate at which something is changing, okay, by relating it, hence the related part, to a quantity which is also changing. Okay? All right. Now, in order to be able to solve one of these, you will know the rate at which one of the quantities are changing, and you have to know the rate at which something else is changing. So like if the radius of something is changing at a rate of blah, 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 what is the rate that the volume is changing? Something like that. Okay. Remember how I said I want you to do dy dx when we were doing implicit differentiation? I want you to write dy dx versus y prime, and I said there was a reason for it, and I'll tell you guys later. Now is later, okay? The reason for that was we need to solve related rates problems using implicit differentiation. All right, so let's review implicit differentiation. So remember when we had something like, let's say, y squared, and we had to take the derivative of it, okay? I kept telling you this at the time, but at the time it's not as meaningful as right now. When I have y squared, that's the variable here is y. I'm taking a derivative of it with respect to x, not y. That is different from if I had ddx of x squared, right? In this case, my variable is x squared, and I'm taking the derivative with respect to that variable. So it's just 2x. But when my variable is different than the variable with respect to which I'm differentiating, then it becomes a chain rule problem. So now I have to do 2y times the derivative of what's being differentiated, which is y, or what's being squared, right? So now it becomes a chain rule problem. So it's 2y dy dt, or I'm sorry, dy dx, okay? Or I could say 2y y prime, right? So same thing. Now, when you're taking a derivative of something with respect to a different variable, it doesn't have to be x and y, right? As long as you're going away from the variable, it could be with respect to anything. So if I wanted to take a derivative of y with respect to x, I could take it with respect to t or r or s or whatever else I want, right? Now that I moved away from the y, I could venture into any other variables. So often, because things change in time, we have to take a derivative of something with respect to time. And that is when we write it like this, ddt. So that means take a derivative of something with respect to t or time. Okay? So we're going to take ddt of both sides of these equations. So the first case, it's going to be ddt of c equal to ddt of 2 pi r. Okay? ddt of c, I can just rewrite that as dc dt is equal to, now I have 2 pi r. R is a variable, 2 pi are constants. I can take it out of the root, out of the derivative, and I could just say 2 pi dr dt. Okay? All right?
So why is it dr?
Because I'm taking a derivative of this, right? I'm taking a derivative of r with respect to t. Okay? So if it was, let's say, if it was 2 pi x, and I wanted to do d dx, what would that be? That would be 2 pi times the derivative of x, which is 1. Okay? But now, if it's d dy of 2 pi x, now it's 2 pi times the derivative of x with respect to y, which is dx dy.
But for some reason, I thought it was like in respect to this situation, it was like in respect to r.
No, so for all of them, it says to take ddt, for all of them.
The only time you would not make it so it's like dr.
Is if these two variables are the same. Yeah, if it was ddt of t, then it would be 1.
It's just weird.
It is weird.
He's not in the equation.
I know. That's related rates. Yeah, now there are 3 parameters, right? Because how often are things just dependent on 1 or 2 things in life? Never. It's different parameters. Okay, so here ddt of a is equal to ddt of half bh. Now, it's ddt of a, different variables, so it's just dA dt equal to, now look at this one. I have ddt, one variable, t, and then I have another variable, b, and then I have another variable, h, right? So this is going to be a product rule, okay? What I'm going to do, though, is I'm going to take this as u, and h is just going to be v, okay? So now, u times the derivative of v is ddt of h plus the derivative of the first one, which is half dB dt, times the second one, h. Okay? And that is how we simplify this one. Yeah. Yeah. Okay. It's very confusing. It's related rates. I told you guys.
There are a lot of letters.
Mm-hmm.
They're like writing sentences.
You're getting into it.
Okay, so here it's gonna be v is equal to 4 pi v is equal to pi r squared h, where h is equal to 4. So let's just plug that in. So v is equal to 4 pi r squared, right? Whew, got rid of one of the variables. So now ddt of v is equal to ddt of 4 pi r squared. Okay, now v and t are not the same variable, so it just stays as dv dt equal to, now I have constant, and then my only variable is r squared. I can pull the 4 pi out. 4 pi comes out. Now I need the derivative of r squared. What's the derivative of r squared?
2r.
It's 2r, but because you're differentiating with a different variable, now it's times dr dt. Okay? So because this is different, you take a derivative. What's the derivative of r squared? 2r. But because this is different, ddt of r. Okay? Let me do another one, and then I'll take some questions. So finally, this will be dv dt is equal to 8 pi r dr dt. Hi. Oh. So d dt of y equals d dt of tangent of theta. Okay.
Oh no.
All right. So dy dt is equal to, now we have to take a derivative of the tangent, which we know is secant squared theta. But what's the derivative of theta? D theta dt.
Oh my god.
So you just treat everything like it's a y?
You treat everything like it's the different variable. Correct. This is why I was making you guys write dy dt before versus prime, because now it's going to be d dt, d dx, d dr, d d whatever. All right. So if you think about it, we have been doing this all along, because when I had d dx of tangent of x, right, that was just secant squared x times the derivative of the x. But because it was dx over dx, it was just 1, right? But now it's dx over dt, you know? It does make sense. It's math.
Because we don't know what it is, so we don't know if it's 1 or not.
Right, exactly. We don't know if, yeah, okay.
DDX of, say, tangent theta, right?
Mm-hmm.
It was
No, it was just, no, it was find the derivative, and then it was like with respect to, yeah. Okay, so now let's actually solve a problem. The radius r, height h, and volume v of a right circular cone are related by v equals 1/3 pi r squared h. It's 1/3 of a cylinder. Okay. How is dv dt related to dh dt if r is a constant? Okay. Okay, so if I have v and I want dv dt, that tells me take the derivative of v. So what I have here is v equal to 1/3 pi r squared h. What I'm going to do is take d dt of both sides of this. Okay. On the left side, I have dv dt. On the right side, anything that's a constant, I can pull out. 1/3 is a constant. Pi is a constant. I'm also told r is a constant. So pull all of these out front. So now I have 1/3 pi r squared dh dt. That's how they're related. Now, how is dv dt related to dr dt if h is a constant? Let's change that to h. You never saw the r. It was never an r. Because whatever is a constant, you're going to pull it out. And this is telling you that r is a constant. Okay, so now it's going to be d dt of v is equal to d dt of 1/3 pi r squared h. Now I want to submit a senior quote.
You should submit one. I'll send you
Okay,
I'll send you the link.
so then dv dt is equal to, okay, whatever's a constant is going to come out. So 1/3 pi h times, now I need to take a derivative
2r.
of r squared. So that's 2r dr dt. But now I'm going to simplify that and say, well, can I just do it right here and save some ink? I'm going to say, whoa. I'm just going to put the 2 here. Okay? So it's 2/3 pi h times r dr dt. Let me do one more. How is dv dt related to dr dt and dh dt if neither h nor r is constant? Now, what if they're both variables? Then we're going to do it differently. So, d dt, yeah, is dd, so it's d dt of 1/3 pi r squared h. Now, so this is dv dt equal to 1 over 3 pi. Can I just write pi over 3? Pi over 3 times d dt of r squared h. Now, if these are both variables, and I need to take a derivative of them with respect to a different variable, that is a product rule. Okay? Yeah. So now dv dt is going to be pi over 3 times. Okay. The first one, r squared, times the derivative of the second, plus the derivative of the first, 2r dr dt, times the second. Okay? This is related rates. So now, what is this? So now you have a cylinder, or it's a cone. You have a cone. The radius is changing, so is the height, and that makes the volume change, right? And so now so all of these rates are related, right? Hence related rates. So now you have to figure out how to solve this problem for one of them. So they tell you, at the moment that the radius is 7 and the height is 3, how fast is the volume changing? And this is what you have to find, because you have to plug in how fast is the radius changing, how fast is the height changing. Okay? Okay, yes.
So for that, so for DBT, it could be like if I wanted to, I would say DVR.
So that depends on the problem. It depends on the problem. Like if something is changing with respect to something else. Okay. The base B of a right triangle, okay, so base B of a right triangle is increasing at a rate of 3 centimeters per second, while the height h is decreasing at a rate of 2 centimeters per second. When B is 4 and h is 3, find the rates of change of the area, the length of the hypotenuse, and the perimeter. Okay, fine. Now, let's draw this triangle. Okay? I have a right triangle, a base B, a height h, and then I'll just call the hypotenuse C because it's always C. Okay, now, B is increasing at a rate of 3 centimeters per second. So the rate of change of B is dB dt. Because, okay, and that's 3 centimeters per second. It's changing at a rate of 3 centimeters per second. Because it's increasing, that's a positive 3. Okay? The height is also it's decreasing at a rate of 2 centimeters per second. So dH dt is negative 2 centimeters per second. Let's see if that makes sense. So the base is increasing and the height is decreasing. So basically, right, that's what's happening, right? Okay, now what I want to find is the rate of change of the area. So that means I need to find an expression for the area. Area is base times height. Times a half. Now, if I want to find the rate of change of the area, that means I need to take a derivative of this. So I need to take d dt of A, let me write it this way, equals to d dt of half BH. Right? So now the half is going to come out. So dA dt is going to be half. And now if it's the derivative of BH and they're both changing, neither of them is constant, that's the product rule. So it's the first one times the derivative of h plus the derivative of b times h.
The dut of the average triangle in the first example, you left 1/2 with it, and you just said u is 1/2 b, and then b is
Right. So either way, and this time I pulled it aside, right?
Yeah.
So it's the same because because we're AP calculus students, and we can deal with constants anywhere, and we can keep track of them anywhere.
Saying, like, is there
No difference. So now I have this expression. Now, do I have anything to substitute in for b? Yes, I do. B is 4. B is 4. It's given to us in the problem. dh dt is -2 plus db dt is 3. And then h is another 3. So hang on. So this turns out to be 1/2. Now, this is the rate of the area. So look at this. It's dA dt. How much has the area changed? Blah, 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 centimeters squared. How much has the time changed? Blah, 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 seconds. So the units are going to be 1/2 centimeters squared per second. Okay? As far as parentheses and brackets, they're grouping symbols, and you can use them in any way, shape, or form that you are comfortable with.
So like, we don't have to, if we put parentheses, we don't have to put brackets because we didn't set anything in yet, or is that?
I mean,
it doesn't matter at all.
no. Yeah.
so
It's in the problem because it says when b is 4 and h is 3.
so another thing, when you had the derivative of e,
Uh-huh.
or you said you subdivided.
Okay.
Oh, so you have the derivative of h and then also times h.
Right.
So you just substitute
Yep.
for both of them.
Yep. No. You were told in the problem that the base is increasing at a rate of 3. And then you're also told that h is 3.
Oh,
So you're
the
just-
h was 5.
Yeah.
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 Okay, good.
Okay. Now, how about the length of the hypotenuse?
So it's a squared plus b squared.
So if I want the length of the hypotenuse, that's you have to figure out now, if I have HB, how do I relate it to C, right? So that's going to be B squared plus H squared is equal to C squared. Now, I want to now, hang on. I want to now take a derivative of both sides of this. So it's going to be d dt b squared plus h squared is equal to d dt of c squared. So here, 2b db dt plus 2h dh dt is equal to 2c dc dt. Now, I have b given to me in the problem up there. I have db dt given to me in the problem up there. I have h, I have dh dt all given to me up there. I'm looking for dc dt, but I don't have c. But guess, yeah? You can find c, right? Because I have this triangle, right? It says when b is 4 and h is 3, right? This is happening when b is 4 and h is 3. So one is decreasing, one is increasing, and then you're sitting there with your camera, you're watching. The moment when b is 4 and h is 3, you take a snapshot, you stop time. That's when we're solving this problem. At that time, c is equal to 5. Okay? So that's what we're going to plug in to c is 5. So this is going to be 2 times 5 times dc dt. And then on this side we have 2 times b is 4. dB dt is 3. Plus 2 times h is 3. dB dh dt is how much? Negative 2. Okay. I didn't have the foresight. I could have canceled out all those 2's. Okay, so finally, dc dt is equal to 6 over 5. This is the rate that side C is changing. That's centimeters per second. Yeah, these are super cool. All right. Okay, so now how about the perimeter? So again, if I want the perimeter, now I need to write a function for the perimeter. So the perimeter of the triangle is A plus B plus C, right? Equals perimeter. So P equals A plus B plus C.
You know, with the number, you aren't using it where you only have the numbers in one perimeter.
Afterwards, you put it afterwards, but you don't even need it. Okay. So look, so now this is going to be dp dt. When you substitute numbers too soon, they all turn into constants and then the derivatives are all zeros. So be careful. You put in constants, you put in numbers after you take a derivative. So dp dt is dA dt. Not dA. This was b plus h. Why did I do a plus b? It's b plus h plus c. So dB dt, oh my gosh, plus dH dt plus dC dt. Okay, so I want dP dt equals what's dB dt? 3 plus negative 2. Plus this one I just found to be 6 over 5. So that is 11 over 5 centimeters per second. Okay, next. The angle theta, where theta is the angle where the base B and the hypotenuse intersect. B and hypotenuse, so that's theta. Okay? And that's H. Okay. We want to write an expression for this. Please, okay, so, yeah, it's tangent. So I like to use the quantities that I was given in the problem. In the problem, I'm given B and H, right? So I want to relate B and H to theta, and that's tangent of theta is equal to B over H. No, it's not. It's H over B. So now, if I take a derivative of both of these sides, then secant squared theta d theta dt is equal to what? Quotient rule. Okay? So b dh dt minus h dB dt over b squared. What am I looking for? The rate of change of theta. I want d theta dt. So what am I going to do? Divide both sides by what? Secant squared theta, right? So if I'm going to divide by secant squared theta, here I want to do times 1 over secant squared theta. So d theta dt is equal to what? Okay, so now, what is 1 over secant squared these days? That's just cosine squared, right? That's just cosine squared. Okay, so, all right, so what is B? What was b? It's still 4 times dh dt is negative 2 minus 3 times 3 over 4 squared times cosine squared theta. What's the cosine of theta when b is 4 and h is 5? No, h is not 5. C is 5. Right? Do you remember? This is a 3, 4, 5 triangle. Right? So what's the cosine of theta?
4.
4 over 5. So times 4 over 5 squared. Now, check it out. 4 squared cancels with 4 squared.
Wow.
So I have negative 8 minus 9 is negative 17 over 25. What are the units?
Degrees.
Huh? Not degrees though, radians per second. Okay? Lovely.
So fantastic.
All right. So,
Page 25, so it's like
yeah.
17.
17 over 25. All right. Okay. I think I will go over how to do this next time. I will stop here. I see you guys again on Tuesday.